Hello students, today we will see Theory Part 8 Chapter 9 of Organic Chemistry, some basic principle and techniques, in which we will cover the NCERT section 8.7.4 and 8.7.5. This is disclaimer. Now in today's lecture, our objective would be to look upon the electronic displacement. So these electronic displacements are very important because they help us to decide the course of a reaction, how a molecule interacts with the other molecule, and what is the product accordingly. Now if I talk about the names of the specific sections of the NCERT, then we will see the NCERT section 8.7.4, which is electron displacement effects in covalent bonds. In this we will see the first type, which is inductive effect. So our today's objective would be focused around this inductive effect only. So we have more types of electron displacement, but that will be discussed in the upcoming lectures. After covering this theory part, we will see some questions. So we will see in-text question 8.14 and 8.15. So let's try to understand what is electron displacement. I hope this term is itself kind of self-explanatory. If I try to define it in simpler terms, then it is shifting or movement of electrons within a molecule. Now, what are the types of electron displacement? On the basis of their existence, we have two types of electron displacement. The first one is permanent electron displacement, which is always present in a molecule irrespective of the given condition. The first type of permanent electron displacement is inductive effect. So we will study this thing today. Then we have the resonance effect, and lastly we have the hyperconjugation effect. We will talk about this resonance effect and hyperconjugation effect in the next class. We will only see today the inductive effect. Then the next type is temporary electron displacement. In this type of electron displacement, the shifting is seen only under specific condition. Most probably those conditions are given in the chemical reaction. So that type of effect is named as electromeric effect. So only one temporary electron displacement is possible, which is electromeric effect. Let's start with the inductive effect. Now it is very important to understand this inductive effect. It will help us to kind of determine two things. First of all, the physical properties, and also the most important, the chemical properties. Now, what is inductive effect? It is a permanent electron displacement through sigma bond. Okay, permanent electron displacement through sigma bond. We have talked about what are sigma bonds, what are pi bonds. Now, why it occurs? It occurs due to the bond polarity between two atoms. Consider a molecule given here. So the X is halogen and the C is carbon. We know it very well that carbon is less electronegative than halogen, and due to this electronegativity difference, bond polarity arises. And why it is arising? To understand this, we will go through a short process. So first thing you know, which is very obvious, is that halogen is more electronegative than carbon. As a result of that, halogen will attract the bonded pair of electron which is present between halogen and carbon towards itself. Okay, so that will create an unsymmetrical pattern of electron distribution. If these electrons are pulled more towards the halogen and away from the carbon, then the carbon will get a delta positive charge. First thing is that, so here the delta positive is representing a small positive charge. Okay, so delta is something which is related to small quantities. What will happen to the electronegative atom? It's very obvious. It will accept electron density and hence it will develop a same amount of delta negative charge. Means opposite charge, once the nature is opposite but the amount is same. Okay. Now this inductive effect that we are seeing right now is somewhat dependent upon distance and it diminishes with the distance increasing. Okay, so as you increase the distance from the electronegative element, the inductive effect decreases. I hope you are getting the point. If you are not getting it, we will try to understand with the help of an example. Okay, at the same time we will also see that what is the effect of distance on inductive effect and why it is diminishing with the distance. Consider the example of chloroethane. Notice how a chlorine atom is attached to the carbon 1 atom. As a result of this connection, you will see an unsymmetrical distribution of electron density. The chlorine will get a delta negative charge. So here your halogen is now the chlorine due to its greater electronegativity. Why it is happening? Because the chlorine is more electronegative than carbon. So it will pull electron towards itself more strongly. As a result of that, the electron will move through the sigma bond. Now that electron movement is shown here by the arrow. Okay, so the electron is moving through the sigma bond and accumulating on the chlorine. Remember, this is very important to remember that your inductive effect operates through the sigma bond. Okay, so the chlorine is getting the delta negative charge due to the flow of electron through the sigma bond from the carbon onto the chlorine. And as a result of removal of the electron density, the carbon one will get a delta positive charge. If you notice, the carbon number 2, it is having a delta positive charge. Now, is this charge greater or smaller? Remember, I told you that delta is representing a smaller quantity. So, if we put 2 deltas here, that means the positive charge is even smaller on the second carbon. Why it is happening? I told you that inductive effect decreases with distance. So, this is the meaning of the distance dependency. You can see that as we are moving farther away from the chlorine, the charge on the carbon is diminishing. What is the reason behind it? So basically, due to the electrostatic interaction between the chlorine and carbon, the polarity is occurring. So it's the obvious thing. So greater is the electronegativity, it is pulling the electron. Now why it is pulling electron? What is the reason of its pull? The reason is the Coulombic force. And you know it very well that Coulombic force is inversely proportional to distance. Means the pull is inversely proportional to distance. Therefore, the electron movement from the second carbon is less as compared to the first carbon because the second carbon is away from the chlorine. And as a result of this thing, the inductive effect is less on the second carbon. So we say that inductive effect diminishes with distance. Now moving on to classification of groups. So we have tried to classify groups on the basis of type of inductive effect it shows. So on this basis we have 2 types. The first is the electron withdrawing group. Okay, the first type of group is electron withdrawing groups. And the second one is electron donating groups. I hope you are getting the point of electron withdrawing groups and electron donating groups. The one species, the one set of atoms which attracts electron towards itself is an electron withdrawing group, and which donates electron are called electron donating group. With this, can you decide that under which category the chlorine will fall? Of course, it will fall in the electron withdrawing group. So let us discuss this electron withdrawing group with detailing. Now, what type of effect is shown by the electron withdrawing group? They show a minus I effect. Now, you can remember it in this way. It is taking away something from the other groups. So, it is kind of putting it in depth. So it is shown by minus I effect. It is pulling electron, it is making the other atom differentiate, so that is shown by the minus I effect. So you can remember this thing in this way. So what is the point? That electron withdrawing group shows minus I effect. Now what type of groups shows a minus I effect? All those groups which are more electronegative than carbon will show a minus I effect, because they are capable of pulling electron from the carbon. So you can think of this like a tug of war. So the one with the stronger strength will pull more towards itself. In this case, that pull is towards the electron. As the electron density is pulled towards themselves, what will happen as a result of that? As a result of that, the positive character on the attached carbon will increase. Okay, so the amount of positive charge will increase. We can just denote the same with the help of this example. You can see here we have a chloropropane. Now the electron withdrawing group, which is chlorine, is attracting electron towards itself. So it can be shown that chlorine is an electron withdrawing group and it shows minus I effect. As a result of this electron pull, the CH2 group is getting a delta positive charge. The electron movement is again shown by arrows in the sigma bond between chlorine and carbon. Okay. Now what else can be inferred from here? Can we depict something about the chemical reaction? Is there any reference from here? Remember, we have talked about the electrophiles and nucleophiles. What are nucleophiles? Which are nucleus loving or which love positive charge. So if a nucleophile comes, where it will attack? Obviously, it will attack onto the carbon number 1, which is having a delta positive charge. Now, this is the reason your functional group containing carbon compounds are more reactive than the normal alkane. It is due to the bond polarity, which results in an inductive effect and a positive charge onto the carbon attached next to the electron withdrawing group. Now, the most important takeaway note from here is the order of minus I effect. Different groups show different order of minus I effect. Here is a list of that. So the most highest inductive effect, minus I effect, is shown by NO2. Then comes your SO2R, then your CN, then your CHO, then fluorine, chlorine, bromine and iodine. Can we rationalize it? Is there a way? Yeah, there is a way. If you look upon the iodine atom, it is the least electronegative atom among all the halogens. As a result of that, in the list of halogen, it is falling in the last part of the series. Then we have the next least electronegative element, which is bromine. Then we have the chlorine, and the highest electronegative halogen atom is the first of the halogen series. You may also ask one question: why are we not taking NO2 less than the halogen? Because nitrogen is less electronegative than fluorine. The answer is that here we don't have nitrogen only. We have a group of 3 electronegative element and a group of 3 highly electronegative element. Although the contribution from one is not significant as compared to the fluorine, but contribution from this 3 atom, which is 2 oxygens and 1 nitrogen, is significant, and hence it will show higher minus I effect. Similarly, the combined effect of SO2R is less than the NO2, but again higher than the halogens. Then we have the CN, then we have CHO, and so on. We have fluorine, chlorine, bromine and iodine. I hope you are getting the idea of how do we rationalize this series. If I ask you that we have a NO2 group attached to a carbon and a fluorine group attached to a carbon, then which one will be more reactive? Obviously, you will say that NO2 will be more reactive one. Means the carbon having the NO2 group will be more reactive one, because it is having a greater charge on the carbon. I would say positive charge on the carbon. So it will attract nucleophiles more easily. Moving on to the next type of group, which is electron donating group. Remember, the electron donating group shows a plus I effect. So it's obvious. So it is donating something to someone. So that can be remembered in a way that due to its donating power, it is showing some positivity. So it is donating electron and hence it is showing a plus I effect. Opposite to that of electron withdrawing group, the Groups which are less electronegative or equal electronegative than carbon will show electron donating effect. What will they do? Due to their higher electronegativity or equal electronegativity, they will push or release electron density away from themselves. As a result of that, the negative character on the carbon which is attached to the electron donating group increases. So they will develop a delta negative charge onto them. Here is an example of that. So the most common example is alkyl group. So we have taken the same example. Now in case of this, rather than attaching a chlorine to the group of 3 carbon, we have attached a R group. So this R group will donate electron density. So this R group will have an electronegativity equals to the carbon or greater than the carbon. So these are the only two possibilities. The third possibility is not considered at all. So as a result of that, they will show a plus I effect. Now you can notice one more thing, that the carbon is getting a delta negative charge, the carbon 1. Then the carbon 2 is getting delta negative charge. So the charge amount is diminishing again due to the distance. And similarly, the third carbon is getting a delta negative charge. So 3 delta, so even smaller charge. Now after this point, the inductive effect becomes negligible. So we can remember this as a point, that after 3 carbon, the effect of electron donation is gone if it is operating through the sigma bonds. Okay, so it cannot be proceeded further due to the large distance. Again, we have an order from the plus I effect. The most electron donating group is Cr3, then we have Chr2, then we have Ch2r, then we have Ch3. Can you rationalize this? Yes, we can rationalize this easily. The carbon which is having 3 alkyl groups are having 3 electron donating group onto the carbon. As a result of this, the donating tendency of this carbon increases. Whereas if we just replace one hydrogen with the alkyl group, then the electron donating tendency will decrease, because alkyl has a greater electron tendency than the hydrogen. Similarly, if you remove one more alkyl group and place 2 hydrogens, then it will be CH2R, so it will show the lower plus I effect, and the least one is shown by CH3. If I ask you, can we have a even lower group? Yes, hydrogen can be a case, but this can be relative. It will depend upon the group to which it is attached. But for now, you can say that hydrogen has the least plus I effect. Okay, and that thing is obvious also, because hydrogen is less electronegative than carbon. So if you increase the number of hydrogen atoms on carbon, its donating capability will decrease. Now, if you are aware about this inductive effect, then we can move on to the application part. This is the most important part, I would say. Understanding the theory is good and no doubt about that, but applying that thing is even better. The first thing is the acidic strength that can be explained on the basis of this electron withdrawing or electron donating group. So if you have an electron withdrawing group, then it will increase the acidic strength by stabilizing the negative charge. Question may arise, where is this negative charge coming on to the acid? You remember that the acidic species are those species which accept electron. According to Lewis, according to Arrhenius, they donate H+. In both the cases, if it is donating H+, it will get a negative charge. If it is accepting electron, obviously it will get a negative charge. So those species are kind of stabilizing the end product. Means if you have to go from one way to other, then wherever you are going, that should be a higher stable position. Okay, think it in this way. Suppose you want to change a job, okay, or say you want to move to a school, from one school to other. What will you expect? You will expect that the school to which you are moving would be a better one. Then and then only will move there. Same thing occurs with this chemical species. So if they are moving on to a different place, that should be a stable condition, right? And if you see the moving condition, then that is a negative charge. And negative charge are stabilized by the electron withdrawing groups or by minus I effect showing species. Therefore, greater is the number of electron withdrawing groups, greater is the acidic strength. We can take an example here. Suppose we have carboxylate anion. How it is formed? It is formed by the donation of H plus from the carboxylic acid. If you attach an electron withdrawing group onto this carboxylate ion, it will show what? It will show higher acidity, because you are kind of stabilizing the end product of the carboxylic acid acidic reaction. But in place of that, if you attach a electron donating group, then that will kind of increase electron density onto the carboxylate anion and hence destabilize it. You can think of it in this way. Suppose there is a society or a country, and a group of people are very rich and a group of people are very poor. If you want that, okay, I want my economy to be better for all the people, what you will do? You will make the mechanism in such a way that the money distribution in the further future occurs in a way that the money is distributed equally, or I would say not equally, but the one which is doing more hard work will get the money, right? But if you do the opposite one, that will destabilize your economy. Similar to that, if something is having a negative charge and if you attach a group which is even donating more electron onto it, so it will act as a burden. Okay, so if you remove the burden, the stability will be higher. If you give more burden, it will destabilize it. Now, can you think of this in terms of scientific attachment? Yes, you know it very well that charged species are least stable. So if you are attaching a electron donating group, you are increasing the charge in a way, so that will destabilize the species. Okay, in place of that, if you attach electron withdrawing group, then that will decrease the charge or it will distribute it evenly, and that will make the species more stable. Then if we talk about the basic strength, then the electron donating group increases the basicity. So opposite to that of the acidic strength, we need an electron donating group to increase the basicity. How can we understand this? Suppose we have two molecules here. One is simple ammonia and the second one is substituted ammonia. It is substituted with an alkyl group. Now that alkyl group will donate electrons onto the nitrogen or electron density onto the nitrogen. As a result of that, the burden on the nitrogen will increase. So here we are talking it in terms of starting species, not the end species. Okay, I have taken both the example. Okay, so here we are starting from the starting species, which is the NH2 substituted with the R. You can think it in terms of end species also, because after the donation of electron from the NH2, it will become a positively charged species, and if you attach a electron donating group, that will stabilize your that will stabilize your end product. But you can start from the starting species also. Suppose this nitrogen is getting electrons. Now to remove this burden, the nitrogen will donate electron, or you can also say that its basicity will increase. Whereas in case of ammonia, we have three hydrogens which have a lesser electron donating tendency as compared to the alkyl groups. So it will act as a weaker base as compared to the substituted ammonia. Moving on to the next application, we have stability of intermediate species, in which we will first talk about the carbocations. So remember, in the previous talk we said that the carbocation with the greater number of alkyl groups are more stable, and I also mentioned that this will be explained on the basis of inductive effect. Now it's very obvious, if you have gone through this discussion carefully, you can easily predict that these electron withdrawing donating groups, which are alkyl groups, will increase the stability of the carbocation. As a result of that, the carbocation with the highest number of alkyl groups is the most stable one. Then comes your carbocation with 2 methyl groups. Then comes your carbocation with 1 methyl group, and lastly with no methyl groups is the least stable. So basically you are going from 3 degree to 2 degree to 1 degree, and the stability of the carbocation is decreasing in this order. Then conversely, if I talk about the stability of carbanion, then their stability increases with increasing number of electron withdrawing groups, because they will lose the burden on the carbon containing negative charge by pulling electron density towards itself. Here we have an example. So the first one is having a negative charge with 3 hydrogens. In place of 1 hydrogen, if you place 1 chlorine, then the burden will decrease due to the electron pull of the chlorine. Again, if you attach 2 chlorine, the electron pull will even decrease. And if you attach 3 chlorine, that will stabilize the carbon with the negative charge highly as compared to the other 3. Therefore, we can say that the stability of carbocation increases with increasing number of electron donating group, and the stability of carboanion increases with increasing number of electron withdrawing groups. Okay, I hope you are getting the point. Now, if we are done with this, we can do some questions on these concepts. Starting with the first one. So, it is problem number 8.14. You have to decide the polarity of the bond in the given 2 pairs of molecule. The first one, we have to decide polarity in the CH bond in the methane and the CBr bond in the bromomethane. Notice how the groups are changed. So we are changing the group from hydrogen to bromine. Of course, they will show different polarity and hence different inductive effect strength. Similarly, if you look upon the second pair, we have an NH2 group attached to the methyl and a hydroxy group attached to the methyl. Again, they will have different polarity and different strength of the inductive effect. So what will be the molecule out of the given 2 in the A and B having the highest polarity? So we'll move on to the answer now. Coming on to the solution, we can say that the CH3Br will form a higher polar bond. Why? Because bromine is more electronegative than hydrogen and it will pull electron density towards itself, which makes the bond more polar between C and Br. Okay, I hope you are getting my point here. Now, if I ask you, out of bromine and hydrogen, which one will show a higher plus I, a minus I effect? Of course, bromine is an electron withdrawing group, so it will show a minus I effect. Whereas hydrogen is not in the league also, it is showing a plus I effect. So, I would say no doubt about this, that the bromine will show a higher bond polarity. Now, moving on to the next couple. So, we have CH3NH2 and CH3OH. So, out of these, the CH3OH will be forming a higher polar bond. The reason is very obvious. Oxygen is more electronegative than nitrogen. So, what will happen? As a result of this, oxygen will pull more electron density towards itself, making the bond highly polar. I hope you got answers of the two as well as the explanation. Moving on to the next question. In this given molecule, which is CH3, CH2, CH2Br, you have to decide that which CC bond is experiencing the least inductive effect. So, we have talked about the distance dependency of inductive effect. So, if you move on to the solution, you can see that the C carbon, which is C3 carbon, is having a greater number of deltas in the positive charge. Now, what can we infer from here? That is having the lowest positive charge, because the inductive effect is diminishing with distance. And what is the reason behind this diminishing quantity? The reason is that your electrostatic interaction is inversely proportional to distance, and electrostatic interaction is the reason for the inductive effect. So, if it is decreasing with distance, the inductive effect also decreases with the distance. You can see it. The first carbon, the carbon 1 is having the highest positive charge, which is delta plus. Then the carbon 2 is having the lower positive charge, which is delta delta plus. And in the given molecule, the carbon 3 is having the least positive charge, which is delta 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 plus. So we can say finally that the effect on the C3 carbon is least due to the Br, and hence it will show the least inductive effect. So this was all from the theory part and the question part. Now we will summarize our today's discussion. So first we talked about the electron displacement. It is simpler terms. If I talk about the electron displacement, then it is shifting or movement of electrons. It can be of two types depending upon its existence. So first is the permanent and the second is the temporary. The permanent consists of inductive effect, hyperconjugation effect and the resonance effect. Whereas the temporary effect will be consisting of the electromeric effect. Then today we talked about only the inductive effect. What it is? It is the electron displacement, permanent electron displacement through the sigma bond. And the reason for this is the bond polarity between the two atoms that is diminishing with distance because of the inverse relation of Coulombic force with the distance. Now, what is bond polarity? It arises from the unequal electron sharing due to the electronegativity difference between the two atoms. Then after, we talked about the types of groups. We have electron withdrawing groups which shows minus I effect. So they are the groups which have a higher electronegativity than carbon, and as a result of that they attract electron density towards themselves. The next type is electron donating group, which shows a plus I effect, so they donate electrons and they have a lower electronegativity as compared to the carbon or equal electronegativity. So they push or release electron away from themselves. Then after, we talked about the application of inductive effect. We talked about 4 applications. The first is the stability of carbocation. So the stability of carbocation decreases, okay, with increase in number of electron donating group and increases with increase in number of electron with the stability of carbocation increases with increase in number of electron donating group and decreases with increasing number of electron withdrawing group. The reason is very obvious. If you are having an already electron deficient species, then you will attach electron donating species to stabilize that or to neutralize that electron deficiency. The second application that we talked about was our carbanion. So the opposite is true here. If you have more electron donating species onto the carbanion, they will destabilize the carbanion. But if you are attaching electron withdrawing group onto the carbanion, they will remove the burden from the carbon containing negative charge and hence stabilize them. Then we also talked about the acidic and basic strength. Remember, upon the removal of hydrogen from the acid or donation of accepting the electron from other species, they will develop a negative charge, and that negative charge is stabilized by the electron withdrawing group. So the acidic strength is stabilized by the acidic strength is increased by the electron withdrawing group. Conversely, the basic strength is increased by the electron donating group because it will force the species to donate electron by giving it more and more burden of negative charge. So this was all for today's class. I hope you enjoyed the lecture. Thank you for joining the session.